Hello there. Now we have a kinematics question between two cars that are basically one is trying to overtake the other. So a car X is traveling at a constant speed u along a straight road. At time t equals to 0, a second car Y is a distance d naught behind car X and traveling at a speed v in the same direction. Now speed v is less than speed u. So we have to understand the question right now. We have two cars, X and Y, where X is traveling with a speed u, and this is constant. Apologies for the bad handwriting. And then for Y, initially we have a speed v, where v is less than u. Okay. Now what happens? At time t equals to 0, car Y, with initially it is with a v, it begins to accelerate with a constant acceleration. That means v increases at a constant rate, because well, as v increases at a constant rate, that means y is accelerating constantly. Okay, so now we can actually draw a graph that represents the relationship between these two X and Y, where we can draw the velocity time graph first, v meter per second, as well as time in seconds. So we have u for car X is basically constant throughout time. So we just label this as u. Now what happens to car Y? Now car Y, initially we have a value, let me just use color red, where v is less than u. And what happens? It begins to accelerate. That means we can expect the graph of the v will be increasing at a constant rate. So the acceleration will be constant in this case. Now car Y overtakes car X at time t equals to t. So we know that means somehow for car Y, initially it is at speed v, it will start to increase. So let's just draw this in a way that we can represent it as this way. Okay, so we can see there are basically three phases of this graph: phase number 1 and phase number 2, and then we have the third phase, which where we can assume that at phase 3, car Y overtakes car X. Now what happens between phase 1 and phase 2? In phase 2, or the similarities between phase 1 and phase 2 is basically during these two phases, car Y tries to overtake car X. However, the difference between phase 1 and phase 2, you can observe here, during phase 1, what happens is that the speed of car X, which is u, is always greater than the speed of car Y, which is v. Only when it reaches this point where u is equals to v. And then during phase 2, what happens is that v is greater than u. Okay. So in this case, what we need to try to visualize is that during phase 1, although car Y is accelerating, however, u is still greater than v. So to answer the question, which graph could best show the variation with time t of the distance between the cars? So that means we need to find out what is the distance traveled by both cars during these two phases. Now, if we have a velocity time graph, that means in order to get a distance time graph, we need to take the area under the graph. So if you observe here, the distance traveled during phase 1 by u, let's just use this color blue, okay, would be much greater than the distance traveled by car Y. Okay, so that means car Y is still lagging behind. That means d naught would for a certain time would increase. That means the distance between car X and car Y would be longer. The distance would be further away only during this short period of time until car Y manages to match its speed with the speed of car X. Only when the speed matches U equals to V, then only the car Y will be able to decrease or to ensure that the distance between both cars is it gets closer basically. Okay, we can actually visualize this mathematically. All right, so basically distance is basically just velocity times time, isn't it? Now the distance between car X and car Y, we can actually use the difference between the two area under the graphs. Okay, so that means d will be equals the distance between car U and car V will be equals to du minus v times t. Okay, so u will be the speed of car X and v is the speed of car Y. All right, now okay, this is a bit confusing on how we're going to explain this, but hopefully I can manage to explain this to you guys. Now since u is greater than v, therefore the distance would be positive. That means there will be an increase in the distance. However, we know that v is increasing at a constant rate. Therefore, the distance would be decreasing. So d is larger, d is positive, but it is decreasing. So d increases at a decreasing rate. So intuitively, we know that the option for C and D are wrong during the first phase, because you need to have this sort of transition where car Y will try to match its speed first before it starts to decrease or it gets closer to car X. Now, so this is during the first phase. During the second phase or the transition, u equals to v. So when u minus v is equals to 0, that means that d will be equals to 0. So when d equals to 0, that means there is no additional distance between the two cars. Now, when v is larger than u, so when v is larger than u, therefore the distance between the two cars would be less than 0. So in this case, when v increases, okay, so when v increases, so that means the distance would be smaller in this case. So here d will be decreasing at an increasing rate. Okay, so you can see here A is not correct because during the second phase you can see that the rate of change would be increasing where D is decreasing. So during the first phase, let me just recap. During the first phase, D increases at a decreasing rate, but during the second phase, D decreases at an increasing rate. So you can as if visualize when you have two cars, the car that is behind starts to accelerate at the same time. Before it starts to match the speed, it will be further apart. And then when the two cars match in terms of the speed, then only it will be able to shorten the distance between the two cars. And as it goes, as it accelerates until a point at time t, what happens? Car Y will be able to overtake car X. So hopefully that answers your question. If you have any further questions, do drop a comment under this video. Thank you very much. Bye bye.